Hello, I'm Pyry, and in this video I will demonstrate how to use an affordable USB logic analyzer to debug a circuit. So, a logic analyzer is a device that reads and records the signals connected to its inputs, allowing you to inspect what's happening in a circuit. Professional logic analyzers from manufacturers like Mechatronics or Keysight can cost thousands or even tens of thousands of euros, but basic USB logic analyzers can be bought for as low as 20 euros. The main limitation with cheaper analyzers are the amount of available channels, i.e. how many signals the analyzer can record simultaneously, and the available bandwidth, i.e. how fast the signals the analyzer can capture. In this video, I'll be using one of the cheapest logic analyzers commonly available, the unbranded LHT00SU1, which I purchased for around 25 euros. As it is a USB logic analyzer, it must be used in conjunction with the right software on your computer. I'll be using the open source PulseView software, which supports this logic analyzer out of the box after you've installed the required drivers. Instructions for installing the drivers can be found from the PulseView wiki along with downloads for the software. In this circuit, I have an ESP32 microcontroller connected to an MPU 6050 gyroscope via I2C. As we can see, the demo code is saying that it cannot find the gyroscope. I will begin by connecting the two first digital channels of the analyzer into the data and clock pins of the gyroscope. I can connect the analyzer in parallel, so I don't have to make any changes to the circuit. Always make sure that the logic analyzer shares a common ground with the rest of the circuit, or else the signals won't have the right reference level, resulting in wrong readings. After connecting the logic analyzer to the circuit, I'll connect it to the computer and open up PulseView. PulseView should discover the analyzer automatically, but if it doesn't, then you can manually scan for it. Select the correct device type and hit scan, then select the device. If your analyzer isn't showing up, then you have most likely chosen the wrong driver or haven't installed the correct device drivers. Next, choose an appropriate sample amount and rate. By default, the ESP32 runs I2C at 100 kHz, so you will want a sample rate that's significantly higher. I'll choose 1 MHz as the logic analyzer can easily achieve it. 1 megasamples at 1 MHz means the analyzer will capture 1 second of data, which is fine. Since the Arduino code only attempts to connect to the gyroscope on startup, I will hit run on the software and then immediately afterwards restart the ESP32. And as we can see, the data shows up. Just the raw data alone isn't that useful though. Thankfully, PulseView has multiple protocol decoders built in. Protocol decoders decode the signal for you, letting you know what's happening. Since the gyroscope is connected via I2C, I'll choose the I2C protocol decoder. Then I'll tell the protocol decoder to look for I2C clock signal on channel 1 and a data signal on channel 0. The protocol decoder has successfully decoded the data and is showing us that the microcontroller is looking for a device at address 69. This is followed by a NAC command, meaning that there are no connected devices with that address. So the I2C communication is working, but perhaps the address is wrong. Looking at the MPU 6050 datasheet, we can see that it has two configurable addresses, 68 and 69. So let's try with address 68 instead. Success! The gyroscope is now working. We can now also inspect the successful communication with PulseView. In addition to debugging, the use of logic analyzers and protocol decoders can be incredibly useful when, for example, trying to reverse engineer the functionality of some device. And for just 25 euros, I feel like it's an irreplaceable tool. I hope you found this video useful. I recommend checking out the SIGROC PulseView wiki for more information and recommended devices if you are interested in purchasing one.